Alright, so today's gonna be molecular formula. So basically what molecular formula is it's an extension of empirical formula. So if you have a molecule, right, like this C13H18, it's it's in its empirical formula form because this 13 and this 18 can't be simplified, right? Because like, well, 13 is a prime number, so obviously you can't divide it, but this molecule is in its simplest form. However, what molecular formula basically is this molecule can be represented in this way, C26H18. Because empirical formula is the simplest representation of a molecule, and some molecules actually don't exist in the simplest forms, what the question will do is they'll give you the molar mass, which is, it'll be like a number in grams per mole. And then what they'll ask you to do is to find the molecular formula, which is basically the state the molecule like actually exists in. So it could be, for like in this case, it could be like C26H18. So the general roadmap for these kind of questions, like these kinds of questions, are basically you find the empirical formula first. And then you take each Okay, so the general roadmap for molecular formula questions is basically you have to find the empirical formula first. And then what you do is you add up all the atomic masses of your atoms in your molecule. So for example, you have CH4. So here you have 1 carbon and 4 hydrogens. So what you have to do is you do carbon 12.01 plus 4 times 1.01, right? Because this is the atomic mass of carbon and this is the atomic mass of hydrogen, and you add that up, you get 16.05. And you take this number 16.05, and then in the question they'll give you like a molar mass, right? They'll give you a given molar mass of, let's say in this example, it's 48.3, right? 48.3. And all you do is you're going to take this given molar mass, and then divide it by what you found, divided by this number. So you can take 48.3 divided by 16.05. It's going to give you roughly 3. And you take this number 3, and then you multiply each subscript of each atom in your original molecular empirical formula by this number. So what this is going to look like is you have CH4, and this is the same thing as C1H4, right? And you take the 1 and the 4 and you multiply it by this number 3. So it's going to turn into C3H12. So this will be your molecular formula and your final answer. So to try this with a question, so you have a dye that has a percentage composition of 75.95% carbon, 17.72% nitrogen, and 6.33% hydrogen, and a molar mass of approximately 240 grams per mole. So calculate the empirical and molecular formula. So remember step 1, find the empirical formula. So we're going to do the table. Table is the best method for empirical formula, trust. And you take carbon, nitrogen, and hydrogen. So remember, only write the atoms. Don't put like H2 in there. You take your mass, and you take your atomic mass and your moles. So your mass, because these percentages here, they all add up to 100. So we can take the percentages as like grams, right? we can take the percentages as essentially the mass, because they all add up to like 100. So you have 75.95, you have 17.72, and 6.33. And your atomic mass for carbon, 12.01, nitrogen, 14.01, and hydrogen, 1.01. And then because mass is equal to Mr. times moles, your moles is going to be your mass over MR. So your mass, your moles, for carbon is going to be 75.95 divided by your atomic, which is 12.01, which is going to be 6.32. And then for nitrogen, it's going to be 17.72 divided by 14.01, which is going to be 1.246. So 1.26. And then for hydrogen, it's going to be 6.33 divided by 1.01, or 6.27. So you take your smallest one here, and then you divide it by, and you divide each other like mole value by the smallest one. So if you divide something by itself, obviously it's going to be 1. And then 6.32 divided by 1.26, I should say, you get 5. And then if you do the same for hydrogen, it's going to be pretty similar, because these two values are pretty much the same. You'll get 5. So your empirical formula will be C5N H5. Good. Or if you want to like write it nicer, it's going to be C5H5N, right? So this is your empirical formula. So let's get rid of we found the empirical formula, so let's move on to the molecular formula. All right, empirical formula C5H5N. And then remember, what we have to do is you add up all the atomic masses of each atom of your molecule. So you have 5 carbons, 5 hydrogens, and 1 nitrogen. And for carbon, it's going to be 12.01. Hydrogen is 1.01, and nitrogen is 14.01. So if you add them all up, it's going to be 5 times 12.01 plus 5 times 1.01 plus 1 times 14.01, or just 14.01. If you add this all up, 5 times 1.01 plus 14.01, you're going to get 79.11. And you take this value, and then you have your 240 grams per mole that your question gives you. So your given molar mass is equal to 240. And you take this 240 and you divide it by the one you found. So this is roughly 80, right? So you take your 240 divided by 79.11, and that's going to give you roughly 3. It's going to be something like 3.1, but it's 3. And you take this 3 and you multiply it by you take each subscript and you multiply it by this number 3. So you have C5H5N, and that's going to turn into C15. It's going to turn into C15H15N3. And boom, that's your molecular formula.